All right, chapter 5. This is problem number 17 from your text, which is also a question that I ask you, but I'm going to actually show you how to do it to help you walk through. Now, I know you're going to be typing out the answers in the boxes when it comes to the problems that I'm asking you to do, but you really do need to be able to do these math problems. And so I'm going to walk you through 17. Now, once again, here is problem number 17 as it's written in the book. And I'll give you a minute to read it. Pause. I don't need to read this out loud. So here we go. The first thing I'm going to do, since I will be using my Q total equation, Q total, is figure out my R values for each surface area. So I need to use each exterior surface. And once again, Q total is going to be equal to the sum of all my 1 divided by R's times their areas. And so I'm going to do all the R's of all my walls. And so this is the material, everything in my walls. And I'm using this table to look up all the material in the wall. So once again, I'm going back to the problem and I'm reading hardwood planking that's in my floorboards, sheetrock covering. So I'm taking all of those and I'm creating an R for each wall. I created an R for all the roof, an R for all my floor, and an R for all my windows. So now I've got the R for each one of those surfaces. I'm also going to figure out the areas of these surfaces. So the Q area for my walls, my Q area for my roof, my total surface area for my flooring, and the total surface area for all my windows. So I'm figuring out all of my total surface areas before I continue on. And you can see that I've got them here. So feet of window, feet of floor, feet of roof, feet of walls. Now I can answer specific questions on each value. One of the things that the house asks me is a change in temperature that happens to be a 40-degree change. And so I can tell you all of the thermal exchange for all of my walls. So I'm plugging it into my value. So it's 1 divided by the R's that I already found and made like a little table of all of my areas for all of my walls times the change in temperature. Same thing with roofs, same things with the floor, same thing with the windows. If I want to know the total of all of this, I just have to add them together. And so I get my total. Once again, you can see that I crossed out any unnecessary units. So feet squared and feet squared crossed out, degrees Fahrenheit and degrees Fahrenheit crossed out. And so all I was left with was BTUs per hour. What would be the percentage of savings in heat needed if the house is insulated with a total of a 6-inch fiberglass in the attic? So now I'm changing the R value in my attic. I'm adding more material to my attic. So for this one, you just do the problem, and I don't want to answer everything for you. So even though it's here, I'm asking you to do this question. So I'm showing you how to do it without answering it completely. So I'm going to take my R values and add them all together in a total. And then I'm going to take that total here and put it here because that's my new R value. So I found my house's original, but I'm adding a 19R insulation. So I'm going to sum them all together, put that sum here, down in this box, divide it into 1, and then times everything up again. Now to figure out the savings, I am now doing an efficiency equation, and that is 1 minus the new total divided by the old total. And so we did efficiency back in module 3, and it's repeating itself. I said everything in this course just builds and repeats on itself, so I'm taking that efficiency, and to figure out my exact savings, I'm going to do this number. Once again, I don't want to give everything away, but I do want to make sure you know what you're doing. Part C, what would be the percentage of savings in heating needed if the house is insulated with a 3.5-inch fiberglass in the wall and the attic stays the same? So now I'm finding my walling material, and I'm doing the same thing, but I'm using my wall. So I used my R roof. Now I'm going to use my R wall for my 3-inch fiberglass. That one I'm going to go back and look up on my table, right? So I'm using everything that I can see here. I'm using all my materials. So I've got my little fiberglass 3-inch, 10.9. I'm going to take my walls. right here, right? And I'm going to add a 10.9 to that number. So make sure that you're doing everything appropriately. Take your time, try to understand why you're doing it. Question 17 is truly what an energy analysis is and does. It takes everything that's true about the home currently, and then it looks at the future retrofitting that you could do, and you can create a cost-benefit analysis to determine whether you should add the money in to do something like insulate this space and make that difference. Question D is the same thing. What percentage of savings is achieved by replacing the single pane windows with the double pane windows? Same thing that you just saw. And then a little cheat sheet on these little bits on how I found my numbers, right? So I already did all this, pretty much laid it out for you, but I want you to repeat. I want you to do it. There is other questions to this chapter that's asking a very similar thing that's a little bit easier. And then I also have the walkthrough video that I did on the Dosery whiteboard, which allows you to see me actually write it all out. But this is a nice slide version for those of you who wanted something a little cleaner in the math. And good luck. If you have questions, once again, as always, post in the module discussion, and I will be off and on every 24 hours just taking a peek to see. And so if I don't get to it on one day, I'll probably get to the next day, just depending on when I looked at the module, but I look at it every day. So good luck. Take it easy. Signing out.